Welcome, Hornets. Today we're going to be taking a look at curve sketching. And I'm going to be doing this in several parts so that we can see how they work one at a time. We're going to start with the basics, and we're going to take a look at the curve we have here. Now, this is a very straightforward curve. It's called a quadratic. We've seen it before. We know that the quadratic opens down, and we can even factor this quadratic by factoring out the 1/2, leaving us with x squared plus the 6x, um, and then let's minus 6x plus 1. There we go. Now, once I have this, I can use my quadratic formula, and I can find out what I've got. After all, I'm looking at negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is giving me x-intercepts that are 3 plus or minus the square root of 32. And this would simplify into 3 plus or minus 2 root 2. So here we have our first step. Whenever we're doing curve sketching, we want to find the various parts. So we have our x-intercepts. I'm going to go ahead and find my y-intercept. I'm going to find the orientation. Now this would be my right and left end rule. So for example, it is opening downward to the left and downward to the right, being the quadratic. Now this is where we start to work with our new material. All of this is our basics. We found our x-intercepts, our y-intercept, our orientation, but finding our first derivative allows us to now figure out a little bit more. In fact, I'm going to use my first derivative test to determine whether I have a relative maximum or relative minimum. Notice that my critical value when f prime of x is equal to 0. This occurs when x equals positive 3, so positive 3 is the critical value. I'm going to go ahead and make my sign chart, putting my factor down along the side, choosing a value to the right, choosing a value to the left. You'll notice we end up having a positive on this side, a negative on this side. According to my first derivative test, when my first derivative f prime is changing in sign from positive to negative, I have a relative maximum. But I also have a positive first derivative, which means that I'm looking at an increasing interval and a decreasing interval. And I'm going to write both of these down as well. So I have f of x is increasing on negative infinity to 3, and f of x is decreasing on bracket 3 to positive infinity. Now the last thing I'm going to do is take my second derivative, and the second derivative is simply negative 1. Well, if I have a second derivative that's simply negative 1, I know f of x is always concave down, and that f of x has no points of inflection. Now, I'm going to have to find what that relative maximum is. It turns out that this is also my absolute maximum. Okay, we're now ready to begin. We have the interval of concavity. So let's just put f of x is concave down on negative infinity to positive infinity. So you notice I've got a lot of information that I've gleaned from this. We've got our x-intercept, our y-intercept, our orientation. We have our concavity. We know about points of inflection. We know about our absolute maximum. We know about the location of our relative maximum, the increasing and decreasing nature of f based upon f prime, and the concavity of f based upon f double prime. I'm now going to go ahead and I'm going to try to graph this. I'm going to start by locating 3. 1, 2, 3. I have my y-intercept at negative 1/2. It's 3 away, so I'm going to go 3 away. 1, 2, 3. So 3, 4, 5, 6, negative 1/2. 1, 2, 3, and 4. That was our absolute maximum. And you'll notice that all I need to do is make sure I place my points in such a way that they go through the y-intercept and the mirrored image. And I now know the location of these x-intercepts. This has to be our first x-intercept at 3 minus 2 root 2, comma 0. And this one right here is our 3 plus 2 root 2, comma 0. Now I'm going to add, I don't need that point right there. I just need the location. I'm going to put my axis of symmetry in. We often forget about this axis of symmetry in quadratics. I'm going to label my upper point. This was 3, 4. This is x equals 3. We have our y-intercept, 0, negative 1/2. I'm going to put my mirrored image, 6, comma, negative 1/2. And then I'm going to box all of my information and I've got everything I need. Right here. This is curve sketching. The idea is to take a graph, a function, and break it down using everything that we know. This will include horizontal and vertical asymptotes. This will include x and y intercepts. This will include points of inflection, maximas, minimas, intervals of concavity, intervals of increase and decrease, relative maximums, relative minimums, pretty much everything we've done. That's the purpose. That's what we've been doing for the last 2 months. All right, so this was part 1, looking at a quadratic. In our next video, we'll be taking a look at curve sketching, and we'll be looking at a cubic. I hope this has helped. Please be aware I will continue to upload more videos as we go. Thank you, be well, and be safe. Good night.